Hey everyone, it is that time again. We are going to be programming in boot sector assembly. Today we're going to say hello world and we're going to do it in color. Now to do that we're going to have to work with video memory. So that's a cool little caveat. That should be fun. And we're going to write in color. Oh, and if you're still watching this video, please do consider subscribing to the channel. It really does help a lot, especially with the channel being as small as it is currently at the time of recording this. Hopefully, if you're not watching this at the time of recording and it's years down the road, the channel has grown and not shrunk. But anyway, if you do like this content, also consider hitting the like button. It helps me to know what content you enjoy and what content to make. So from our Hello World Again program, you'll remember that we had this program. And let's make sure it still works. Oh, that's always a good sign. It works. So the reason it works is we're saying it's 16-bit. We have the proper origin point here. We're using video mode 3, which does give us the ability to use color. And then we also are setting AH to the letter E, which is the hexadecimal. Well, it's not the letter E. The hexadecimal character represented by E, which is the number 14. If you don't remember the hexadecimal stuff, what is a byte? Video will explain that to you. And when you work that with conjunction with 10H, the upper byte, which is E, works with the lower byte, which we're going to set to our letters here, and it displays those letters on our screen. So we use the string source index to store this address where this string is located, and then using load string byte, it'll actually pull it into AL. This is a little check to make sure it's not a 0. If it is, it breaks out of our loop and ends the program. Otherwise, it calls 10H and it displays it on the screen. So to display colors, we're going to have to work directly with video memory. And when you're in video mode 3, this location is B800. So we have to find a way to store data at B800. You'll remember in the video where I work with variables that you're actually able to use store string byte, so STOSB, and we used a label. So we're able to store data at addresses in memory, so that's a good sign. We're going to be using that again, but we have to store it at a different location so that it shows up on the screen. Now the way the computer works is anything at B800 to this location in memory is what actually shows up on our screen. So B800, B802, B804, and you're probably noticing I'm counting by 2s. And the reason for that is it actually uses words, not bytes. So the upper byte in the word, which would be like the basically where this AH is currently occupying, is where we're actually going to store our color information, and then AL will get stored into that memory address. And if you're thinking, well, then the colors at B800 and the words at B801, remember this is little endian, which means everything is saved backwards in memory. And if that's confusing, I guess it kind of is. But the what is a byte goes into great depth explaining that. So you can watch that video for that as well. Anyway, enough chit chat. Let's actually get into this. So looking at load string byte, obviously this is working because hello world again is on our screen. So let's look a little bit at that. We can see it uses the data segment as the base memory address. So obviously that's working. That's exciting. And then it uses this as an offset, the string index, the source index. If we look at store string, it uses the extra segment. So if we store B800 into the extra segment, then if DI is 0, it will start at that first location, and as it increments it, it'll automatically write it on the screen. Perfect. So let's store B800 into the extra segment. And this is not going to work. But I will show it not work because maybe you don't believe me. Save it. Make it. Error. And the reason for that is we cannot store immediate values into the extra segment. There is no way to do that. So, and this is immediate value, which means it's a number. You can't store this number directly into the extra segment. So what we need to do is store it into a register that does allow immediate values. And AX happens to support immediate values, so we will store it into AX, and then we will move it from AX into ES. Now, I said that we're going to be using store string, this time word, store string word, to display things into the video memory, and it works off of AX as the register. So let's keep track of what's in AX. Right now, AX equals B800. So what we want to do is that upper byte AH is where we're going to actually store our color information. If we go to osdev.org under the text UI, you can see that it's explaining how this byte works, and essentially this byte is background, this byte is foreground. Since black is 0 and blue is 1, that'll give us blue text on a black background. So why don't we use that? That sounds like a good example. 0, 1. And what we'll do is we'll say blue on black. Okay, now we have blue text on black backgrounds. We still do need to set AL. So right now AX equals, we just changed this to 0, 1. And we need to find a way to set AL, and we already have a means of doing that with all of this logic. So when it runs through here, it will set H into AL on the first time it runs through, and H is capitalized, so it is in hexadecimal the number 48, it appears. So now this will equal 0148, and that'll give us a capital H in blue on top of a black background in AX. All we have to do now is store AX into that proper spot. But you'll notice DI is not set yet. Remember that it's going to store it wherever ES is plus DI. Now we could just simply do move into DI 0, but that takes up more memory. And what we want to do is, we don't care about any flags at this point, so we're going to do XOR DI DI. Sort of like we did OR rather than compare. XOR is going to set this to 0. Whenever you XOR something against itself, it means the equivalent of 0 it all out. Handy little assembly trick there. 0 out DI. All right. Now, instead of 10H, what we're going to do is store string word. And remember, since it's a word, it's going to, it's not going to just use AL, it'll actually use all of AX. So it'll store all of this into memory for us. So we'll say store to video memory. And at this point, we actually should have a working program. And I said I was going to say hello world in color, not hello world again. Let's make sure I keep my promises here. Make run. There it is, moment of truth, blue on black. Now, is that hard to read? Yes, it is. Let's pick a different color. So let's use light gray. So that's the number 7. And this first one is our background color, so let's set it to 7. So now we should have blue on light gray. Save that, make run. There we go. So we have successfully shown Hello World in color using boot sector assembly. And that's all that I had for you today. So we do look forward to seeing you in the next video. I almost said please subscribe, but you've already done that. So I don't have to worry about reiterating that over and over. But I do enjoy having you watch my videos. And I do look forward also to seeing you in the next one. So we will see you next time.